I got a question from Harry about the sort of LSAT games question, which pair of variables cannot both be included? So mutually exclusive variables. Great question, comes up a lot. In this particular game, or this particular conditional chain, which rule expresses that kind of relationship? So in this diagram here, can somebody tell me what's a pair of variables that could not both be in or positive? Anybody want to share? So we got a couple of responses here. We got P and B. We got Q and Z. We have X and Z. Nice. All right, so I would say Q and Z is good. Q in requires Z out. So if you have one, you cannot have the other. So that pair of variables, you couldn't have both. Also, X and Z, you couldn't have both. X in requires Z out, requires having this conditional chain, but that's good. But P and B, the problem is that we've got a dotted arrow here. So if P is in, then Q is in, then Z is out, then at least one of A or B is also out. But we don't know which one. So it's possible to have P in as well as having B in, but maybe we would lack A. In fact, if B was in, we would lack A in that particular instance, since we know that at least one of those two has to be out. So dotted arrows are a bit more nuanced than solid arrows are, which is why I express them this way to make it more clear. But yeah, interpreting these chains is a whole separate thing. It's a lot of work to get used to this sort of diagramming language. Thanks for tuning into the show. Please subscribe if you haven't done so already to be notified of new episodes as I release them. And feel free to reach out if you need anything at all as you move forward with your prep. I'm happy to help however I can. In the meantime, I'll wish you all the best and take care.